Thanks very much. So, yeah, as you said, I'm Shaun Taylor-Morgan, and I'm going to be talking about Python in the web browser. So that's using Python to build dynamic web UIs rather than needing to use JavaScript. So let me tell you about me. I used to be a back-end Python developer, and then I got a job also writing front-end JavaScript code. Now, I basically had to think in two different ways. I was using two, fairly languages that fill a similar niche. They're both dynamic scripting languages, but they use slightly different ways of thinking. So as a Python programmer, I want to use classes, and especially if I'm building a web UI, I've got something that's inherently object-oriented. My button is a type of input device, so I want an inheritance hierarchy. But in JavaScript, at least at the time, and at least in native JavaScript, vanilla JavaScript, there were no classes. There were also no keyword arguments, and I want to know what self means at any given time, whereas in JavaScript you have this variable called this that changes its meaning depending on context, and I always find that very confusing as a Python developer. So I was just thinking, why do I have to use JavaScript? Why am I constrained to this one language? Imagine if Microsoft Windows only let you write Ruby. It would not be a very popular operating system. And yet web browsers, they're this application development and delivery platform where you can really only use one language. I had this question in my mind. I came to this conference a couple of years ago, and I saw the Anvil stand. And I saw that with Anvil, you can write Python in the web browser. And then I ended up working for them, so that went well. This has been on my mind since then, and now I've kind of looked at the open source options for doing this, and that's what this talk is about. So I'm going to kind of take you on a tour of what the open source options are. They all have different, kind of fulfill different niches, have different design trade-offs. So I'll take you on a tour and tell you what you should use for what, basically. So you won't be able to see this even from the front, but this is a rather large table of all the different options that you have. It's not written by me, and it may be a bit out of date, according to the author, but it's a good place to start to find out what you can do. It's at tinyurl.com/python-browser-table. So you can go there and find those things out. I'm going to talk about 6 that are kind of representative examples. So they're relatively mature technologies, and they fill the various different areas of the design space. So I put them on a two-dimensional diagram. On the y-axis, we have how do they work, so how is the Python actually running in the browser. We either have Python being compiled straight to JavaScript, so we have JavaScript that sort of has a one-to-one relationship with the Python that you've written. And on the bottom, we have technologies that actually implement a Python interpreter, and in 2 cases, a compiler as well, in the web browser, so either written in JavaScript or WebAssembly. On the x-axis, we have when does the Python get compiled, because Python needs to be compiled to bytecode, which is then run by the interpreter. So on the left, we have compilation happening ahead of time, so you have to compile your Python before you run your web page. And on the right, we have the Python being compiled after the page is loaded. So you can actually have an interactive terminal in your web browser, a whole Python environment in your web browser. In the middle, we have Python, which tries to give you like a Python script tag, so that happens when the page loads. And we'll get to that in a minute. So I'm going to, for 5 out of these 6, I'm going to show you a live demo so that you can see that it's real and it's not just me saying words. So the first we'll talk about is Transcript. So this is something that compiles Python into JavaScript ahead of time. And I'll show you a quick example. So I have 2 files here. Can everyone see this at the back, more or less? Great. So I have hello.html and hello.py. Hello.html is an incredibly simple HTML file. It has an input box and a button. And when I type my name in the input box and press the button, I'm going to get an alert. The dynamic behavior is done by this script that I'm importing up here. And the script is compiled from hello.py. So this is not quite the most simple Python script you've ever seen because it has to access the DOM. So there's a greet function here that runs an alert, and it uses getElementById to get the namebox value. Then I'm binding that to the click handler of the button using document.getElementById. So this is a very JavaScript-y way of interacting with my UI. This is a deliberate design choice by Transcript. So they basically implemented the same syntax as you use in JavaScript for accessing the document object model, the DOM, because they want you to be familiar, if you've used JavaScript before, and you can read the JavaScript docs and work out what Transcript is going to do. So I compile that to JavaScript by running transcript -n hello.py. So now it's given me a directory called dunder_target. I'll just put that at the top. And that contains my compiled JavaScript file, hello.js. So this is actually relatively readable. This is very similar to the Python that I just had. So I've got the alert, I've got the document.getElementById. The main thing that's changed is the function definition is very JavaScript-y, and in my opinion, not as pretty. And then there's this massive import statement at the top. So this is importing a bunch of things that you're probably familiar with from the Python built-ins, but they're not actually Python, they're JavaScript implementations of those things. So they're all in this org.transcript.dunderruntime.js, which is handwritten JavaScript implementations of things we love from Python. For example, Python has a callable function that tells you if an object can be called. The JavaScript implementation of that is a single Boolean expression that checks if it's an object and then checks if it has a dunderCall method. So this has been handwritten to replicate the behavior of Python. And there's also this hello.project, which is some metadata that the compiler likes to have. So I'll show you what that actually does. So we have our input box and our button. And if I type PyCon UK, hello PyCon UK. So I've written some JavaScript, and I've got a dynamic web application, albeit the simplest one you can imagine. If you don't believe me, here's my input box and button in the HTML, and here's my auto-generated JavaScript. So that's Transcript, and that's quite exciting, because I've written some Python that runs in the web browser. But it's not exactly a sort of switch-in one-to-one replacement for JavaScript yet, because I can't write a script tag that contains some Python. If I want to do that, I can use Brython. So Brython gives me a compiler that's written in JavaScript, so I can run it with my web browser. So let's look at the same example, but this time written in Brython. So now I only have one file, hello.html. And I still have my input box and button, as before. But now I have a script whose type is text/Python. So not application/JavaScript, text/Python. And I've got some import statements. And then my Python is very similar to what I had before. But the way I access the DOM is a bit more familiar to me as a Python developer. So I'm accessing the DOM as if it's a dictionary using square bracket notation. And my bind method is nice and succinctly named as well. So things are a bit more Pythonic here. The way that runs is I have this script tag where I'm downloading the Brython compiler from a CDN hosted on Cloudflare. And I get this Brython function in the global scope that I can call. When I call that, it looks for script tags whose type is text Python, and it compiles the Python that it finds. So basically, when the page loads, it's going to find all the scripts and turn them into JavaScript. So now my example is going to look very similar, well, identical. It does exactly the same thing, but when I inspect it, I actually have my Python in the page source. And I could modify that and rerun the compiler. So I've changed the hello to hi. Rerun the compiler. And now I actually have two click handlers. So I have hello PyCon UK and hi PyCon UK, because it's bound both of those and they're still in memory. So that's great now because I have essentially Python instead of JavaScript. But I still have something that runs that I need to write my Python before the page loads. So what if I want to have a REPL? What if I'm, say, running an educational project where I want to give students a URL they can go to, and then they can play with Python? That's what Sculpt was written for. So Sculpt was written for education. And it's really great if you can just give your students a Python environment in their browser, because they don't have to download Python, and they'll probably ruin their system Python in the process. They might get it wrong, so you've got n environments for n students, and you have to debug all of their environments before they can even write a print statement. But if they have an environment in the browser, then you know exactly what they're doing, and they can just go ahead and do it. So the typical Sculpt example is something like this. So I have somewhere I can write some Python, and somewhere where the output arrives. I can run it, and it gets compiled after the page is loaded. It doesn't make any HTTP requests, and some Python gets printed. So I can add some more Python. And run it, and I get some output that some output from Python that didn't exist when the page loaded. So there's a really cool project called Trinket.io that gives students like a Python interpreter in the browser, and that's based on Sculpt. So let me show you the source code of that page, so you'll see how it works. So I have my text area here. That's where you enter your code. I have my output text area there. And I have my button that runs this run it function when you click it. Up here, these are the script tags where I'm importing Sculpt, as I had with Python. And here's a bit of JavaScript that does the compilation. So you get this object called sk in the global scope. This is an object you can just pass it in a string of Python code, and it will compile that and run it as JavaScript. So you can pass it Python code as much as you like. So I'm getting my Python code from the your code text area using the JavaScript way of accessing the DOM, literally the JavaScript function, and then I pass that into sk. So this is kind of an important point about design trade-offs. In this case, I have to use the JavaScript way of doing things to access the DOM. Sculpt doesn't have any built-in JavaScript API, DOM API. But that can actually be a good thing. So for example, so Sculpt is what we use for Anvil, and we're core contributors to it. And we like the fact that it doesn't have a DOM API, because we built our own way of accessing the UI that's more object-oriented. So you're not querying a document to find something. You instantiate an object, and you can pass that instance around and do things like that. So we actually are quite happy that we didn't have to reverse engineer the DOM access layer of Sculpt. We could just build our own one straight off. So we're halfway there. We've looked at all the technologies where Python is being compiled straight to JavaScript. Now I'm going to talk about things that actually implement a whole Python environment, a Python interpreter in the web browser. So that, writing a Python interpreter and compiler in JavaScript sounds like a lot of work. But PyPy.js found a way around that. So instead of basically rewriting Python, which would take years, they recompiled PyPy to work in JavaScript. So they took the C part of PyPy, and they shoved it through this C to JavaScript transpiler called mscripten. So that gives you a JavaScript version of PyPy. They didn't stop there. They also built a just-in-time Python to JavaScript compiler for bits where that's efficient. And that compiles to like a kind of assembly language minimal subset of JavaScript that's easy to optimize. So it's quite a sophisticated, heavyweight tool. And the download size kind of reflects that. So it's 12 megabytes of JavaScript that your browser downloads. And even if you're caching that, your browser has to parse that every time the page loads. So the trade-off for having this fully featured Python interpreter in the browser is that you have to wait for it to kind of fire up. So let me show you an example, and you'll see what I mean. So another HTML file. These are script tags where I'm just importing the interpreter. And I get this. So when those are imported, the interpreter is loaded into the browser's memory, and it starts running. And I get this PyPy.js object, which allows me to interface with that interpreter. So here, I'm just calculating the first 10 square numbers using this exec method. And then I've got these get and set methods where I can pass variables back and forth between JavaScript and Python. So I'm getting the y value, which is an array in JavaScript, and then I'm printing that in an alert. And it's got this nice, promise-based way of doing things asynchronously as well. So, PyPy.js. So we're now waiting for the interpreter to fire up. There we go. And that's my alert with my first 10 square numbers. So this is great if you want to have something that you're familiar with that really feels like Python. If you're doing like an interactive REPL, or you're doing, say, data visualizations, where your users are happy to wait for things to load up, but then things need to be really fast, and you need to have lots of features. For example, it has like an in-memory file system. So you can actually write to files that are stored in your browser's memory, and you can read from them. So that's a really nice feature. It also has something where you can run multiple interpreters, and you can sort of do coroutines between them. So it's got loads of things, but it is very heavy. So the next thing I'm going to talk about kind of solves the problem of the large download. So it's called Batavia, and it's by Beware. They're like an open source project where they make lots of really cool Python tools. Batavia is their Python in the browser solution, and they have literally handwritten a Python interpreter in JavaScript. They haven't written the compiler, so the result is there's this really, memory-efficient interpreter that's only 400 kilobytes to download. The disadvantage is it runs Python bytecode, so you have to put bytecode in your HTML. So here we have a script tag whose type is application/Python bytecode. Although that doesn't look like bytecode, that's actually base 64 encoded bytecode. So not very human readable. So you can compile your Python ahead of time, put it in your web browser. Their Getting Started guide actually suggests that you have a server on the back end that you send your code to, it compiles it, and then it sends it back. So you can do this kind of, you could have an interactive REPL, but every time you press run, it would make a HTTP request. So you can compile at runtime, but you have to do a round trip to do that. The other thing is, of the technologies I've talked about so far, this is probably the most immature. On their GitHub page, they say that it's in early alpha, and if it breaks, you get to keep all the shiny pieces. So if this is something that fills a niche that you need filled, you'd do well to get involved and help them bring it to a more complete state. This is why I don't have a demo of it, actually, because I had trouble getting the Getting Started thing to work. Last but not least, I want to talk about Pyrite. So this is really cool. This is like a Jupyter Notebook, but it runs in your browser. So you can have data pipelines, data science pipelines that are fully in the client. So there's no round trips, and everything's a lot faster. So this is run by Mozilla. They came across a CPython interpreter that's written in bytecode. Sorry, not bytecode. WebAssembly. So WebAssembly is like an assembly language that runs in your browser. So it's faster and more efficient than JavaScript. So they came across an interpreter, and they also recompiled things like NumPy, Pandas, SciPy, all the data science libraries into WebAssembly. And the result is essentially the holy grail of data science. So this is their example notebook. So Pyrite is part of Iodide, which is a bigger project that has JavaScript and other features. So if I run this Python step here, as with PyPy, you have to wait a while for the interpreter to initialize. But once you've done that, you have Python running. So I've printed the version. And now when I run subsequent Python steps, they execute pretty much instantly. But I also have, I can write HTML, I can write Markdown, I can run some JavaScript, I can do all sorts of things. And importantly, it's all in the browser. There's no round trips to a server like you have with a Jupyter Notebook. You don't have to host it. You're using your user's compute, so it scales, order constant. But there is this kind of wait for the thing to start up. So if you needed it for like an e-commerce site, then your users would get bored waiting. And as far as I know, it's tied into the Iodide project. So if you wanted to use the interpreter for something else, you'd have to, it's open source, so you'd have to fork it and try to sort of hack out the actual interpreter. So this concludes our tour. I hope you've enjoyed it. This table, I've got a summary table of all the technologies I've been talking about, which is at tinyurl.com/Python browser. That's a blog post I wrote for Python tips, so it says mostly what I've said here, but it has this table. But I also want to make a broader point as well while I have you. So we've kind of been talking about, as I said at the beginning, why do I have to write JavaScript? Why are there not many options for what language I can run in the web browser? And I think we need to kind of be asking that question about the whole web stack. So the web stack started out as the thing on your left, where you're using SQL for your data access, you have to convert things to JSON, you have to write HTML templates, you have to use the document object model to access your UI. But we're beginning to move to something where we can use Python everywhere. So we have ORMs like SQL Alchemy to write Python to access our data. Obviously, we have Python on the server. We now have Python in the browser. And for example, with Anvil, we have access to a more Pythonic way of accessing the UI. And I'm sure there are other ways of accessing the UI in a Pythonic way as well. So essentially, we can access our data in one way on the server and have exactly the same representation, the same syntax in the browser. So all of that code, the average web app is like 50 lines of code to translate data and 2 lines of code that actually does something. But if there's no translation necessary, web development could be way simpler. And obviously, we don't have to use Python. It could be JavaScript, it could be Ruby, whatever we're happy with. So thanks for listening. This GitHub repo has the examples. That link there is the link to the Python tips blog post that I mentioned. Yep, you should try Anvil. It's free, and it simplifies the web stack, as I've explained. So it's fun, and have a go.
Thank you, Shaun. That was amazing. I've tried Anvil, and it worked really well it's very comprehensible, so I'll encourage you all to try Anvil. I look forward to try Pyodide, and I think we have time for one question, and then we'll have a coffee break.
Thanks for your presentation. Could you please demonstrate the previous slide with your vision how that all should work? How that object on the first two layers will appear on a client device?
So you mean how the top part of the diagram,
Yes.
basically? So
Will you send Python objects directly through the network to a client device?
yes, that's what Anvil does. So it serializes it behind the scenes. So you can literally send a Python object from the client to the server.
I hope you understand that it's the most vulnerable thing you can do to
It's
send.
the most what, sorry?
Vulnerable thing you can do is to send the object through the unreliable network to a client device, which will execute on the client's hardware.
Yeah, well, I mean, obviously, so you set up the permissions correctly, right? So, for example, with Anvil, if you want to execute code on untrusted hardware, we have a client mode that only has the permissions that the web browser has. So then you're safe.
Thank you very much. Let's give Shaun another round of applause.